The topic of this video is analyzing the graph of a rational function. This is a continuation of the previous video. Alright, so we're still dealing with the function r of x equals x squared over the denominator x squared plus x minus 6. We've completed steps 1 through 5, so in this video we will complete step 6. Alright, so let's go ahead and begin. So step 6 asks us to use the zeros of the numerator and denominator of r to divide the x-axis into intervals. Note that we're back to using the original r function provided at the beginning of the problem. Determine where the graph of r is above or below the x-axis by choosing a number in each interval and evaluating r there. Plot the points found. Okay, so that means that we need to find the zeros of the numerator and the denominator for this function. Let's label that. This, of course, up here is the numerator, and this, of course, down here is the denominator. Step 6 specifically says we're back to using our original function, that's the one in standard form, not the one in factored form. Although, interestingly, for this problem, they are equal to each other, and therefore you could use either one, since there was no reducing when we converted from standard form to factored form. But we'll follow the rules, and we will use the original equation, the one that was given to us in standard form. All right, here we go. So we'll start with the numerator. The numerator says that we should take that polynomial and set it equal to 0. So we have x squared equals 0. We can solve this by factoring, so we get x times x equals 0. By the zero product property, we get x equals 0, x equals 0. And therefore the only solution we have is 0. We're going to create a number line, and we'll put 0 on the number line. Now we move on to our denominator. Okay, our denominator is x squared plus x minus 6 equals 0. We'll solve this by factoring. This factoring has already been done in an earlier video. So x plus 3 times the binomial x minus 2 equal to 0. By the zero product property, x plus 3 equals 0, or x minus 2 equals 0. And we get two solutions, x equals negative 3, x equals 2. And we'll put those on our number line as well. Okay, so as you can see, there are 3 zeros of our numerator and denominator. 0, which came from the numerator, and negative 3 and positive 2, which came from the denominator. Now we have to identify within each one of the intervals created by these numbers a value of x to evaluate. So let's be very clear with what we're doing here. We're going to find a value of x that is less than negative 3. We're going to find another value of x that is between negative 3 and 0. We're going to find another value of x that is between 0 and 2. And we're going to find another value of x that is bigger than 2. We are using this value of x to plug into our original function. So we want to use convenient numbers, not messy numbers. So let's go ahead and make that selection in each one of our intervals. To the left of negative 3, I choose negative 4. It's a convenient number, it's close to negative 3, it's still an integer, which means when we plug it in, we won't get crazy, messy numbers. Between negative 3 and 0, I choose the number negative 1. Between 0 and 2, I choose the number 1. And for the number larger than 2, I choose the value 3. So let's go ahead and fill in these 4 points. We have the x's, negative 4, negative 1, 1, and 3. The only thing left to do is to find the y values that go with those x values. All right, so let's go ahead and do that. I'm going to clear a little bit of space over here. All right, let's plug into our function one value at a time. We'll start with the -4. Make sure I do a very good job drying this so that the marker will be able to write on the surface. Okay, if x equals -4, then r of x, or y, would be equal to -4 squared over -4 squared plus -4 subtract 6. Okay, let's simplify this. -4 in parentheses squared is a positive 16. So therefore this is also a positive 16. Then we have -4 minus 6, which is 16 over 16 minus 4 is 12, minus 6 is 6. 16/6 reduces to 8/3, and when we put that in a calculator, we get 2.6 repeating. So 2.6 bar. Okay, let's try our next value of x. If x equals -1, then r of x, or in this case y, would be equal to -1 in parentheses squared over -1 in parentheses squared plus -1 subtract 6. -1 in parentheses squared is +1, so this is also a +1, -1 minus 6. So 1 minus 1 is 0, minus 6 is -6, so we get -1/6. When we put that in a calculator, that is equivalent to the decimal -0.16 repeating. So I'll put a bar over the 6. Okay, 2 points left to go. Let's erase to create some space. Next value is 1. If x equals 1, then r of x, or in this case y, would equal 1 squared over 1 squared plus 1 minus 6. 1 squared, of course, is 1 in this spot and this spot, plus 1 minus 6. So we get 1 over, 1 plus 1 is 2, minus 6 is -4. So -1/4, which when we use our calculator is the decimal, -0.25. There's no bar over the 5. This is not a repeating decimal. This is a terminating decimal. The calculator shows the exact value, -0.25. All right, last value of x. If x equals 3, then r of x, or in this case y, equals 3 squared over 3 squared plus 3 minus 6, which equals 9 over 9 plus 3 minus 6, which is 9 over 9 plus 3 is 12, minus 6 is 6, 9/6, which reduces to 3/2, which is the decimal 1.5. That is also a terminating decimal. It will not need a bar over it. 1.5. All right, so we've identified the points that we will need to put on our graph. We have now completed steps 1, 2, 3, 4, 5, and 6. All that remains to do is to put all of that information together to create our graph, and we'll do that in our next video.